Hello, good morning. It's morning, we got morning energy. And it's time to clean up our code and pretty it up, tidy it up, and make it better, whatever that means. So we got this car controller. Not a very good car controller. I wouldn't use this in an actual project, but it's going to serve as our example. And here's the script, right? Basically, we do everything in fixed update, except for capturing input. Because we remember that we can't capture input inside of fixed update. That's going to cause us bugs. So we store those in some variables, and then we use them in fixed update. Because fixed update and update happen at different times. You could have 3 or 4 or 5 update loops before fixed update, or vice versa, depending on how your game is going. Fixed update happens at a continual time step, and update happens as fast as it can. Anyway, so we need to pause while this truck goes by outside. Okay, so what we actually need to do, aside not from fix my audio, is to clean up this code. So this code works fine for the computer. Unity, C#, the compiler, the computer, whatever you want to call it, it reads the code just fine, and it runs it just fine. It's breaking out now because I have a 3D mouse thing that's being read as a joystick input, and it's spamming up left. But that's not the code's fault. The problem isn't on the computer side of this code, understanding and running it. The problem is on the human side of this code. I can't look at this and understand what it does. This code is very prone to bugs and errors, and it's difficult to use. So we need to make this better for humans. We need to make it better for humans that are using it in Unity, and we need to make it better for humans that are using it, the code themselves, easier to understand. And we need to make it easier to change in the future. So let's go through these in order. The first thing we're going to do is fix up our serialization. So I have a separate video and a description explaining that. Let's take a look at the problem with this one. We want to write scripts that can just be used in Unity, that can just be used without having to dig into code, right? Let's say let's just say I'd manually set that variable, and every time I wanted to change it, I had to go up here and change it. That wouldn't be very good. It would be better to make it public and have Unity allow me to change the value, so I can make the car go faster or slower by changing it. So that one's good. But these TS and RB, these aren't very good, because these variables, even if we change them or assign them, it doesn't matter, because Unity will immediately change that code for us to our input axes. Right. So these are not things I can configure. I look at that, I don't know what it means, and I see it there, and I don't know how to change it. And it turns out that that's actually not a setting for me to change about my car behavior. It's just like a variable that's public so I can look at it. And that's no good. So we're going to change this to private. We're going to change the float to private. And instead of assigning by dragging and dropping the rigid body onto the car, that phone ding was me, you didn't get a message, I did. Instead of dragging that rigid body onto the slot, we're going to use a get component call in awake. That code's already here. So we can make that private. And now this variable will get assigned in awake. For what it's worth, there's a very easy way to do that. Select your thing, hold Alt Enter, go to initialize and start. I prefer to initialize in awake, so I just tap right. And that code is generated for me. Brilliant. So now my serialization is, it's a little bit better. I got my motor force there, and I got my car. Let's, but we don't want that function to be public. We want it to be private with a serializable field. That way other scripts can't edit it. Unity Editor can edit it because of the attribute, but other scripts can't edit it because it's still private as far as the code is concerned. And that's what we want. And that's good. So turn force, it'll have a default value of 10. Let's give a default value of 10 for the motor force. Because we're smart, we know that these values won't be changed in the Unity, like if we change in the Unity editor, these values will get ignored. But now if I were to add this script to a game object, it would populate with those values by default because it's going to use these values right here. Let's add a header and call it config. Let's add a tooltip and say driving speed of the car and tip for the how fast the car should turn. That's not a very accurate description of like the physics involved, but it's not a very accurate simulation of a car, so it's fine. And now I have that word config there, and I can hover over that and it gives me a thumb tip. I can set this value to be a negative value, and then when I hit play, I go forward and it's going to go, I have my problem again. But I can set it to a negative value and that's no good. So we're going to add a minimum value to attribute to our field as well. And we'll do that to the other one too. Attributes might be easier to understand if you think of them as like a single line. They always just apply to the next thing. And even header is technically only being applied to this next property, even though in Unity it's it kind of is used to categorize. So now I can't make it less than 0. Great. Gosh, I keep alt tabbing into this clip. Okay. That's all right. There's more we could do. There's more attributes we could use, but that's all right for now. We could set a max or a range or something, but that's fine for now. So now it's easier to use in our projects. It's easier to look at and edit and know what to do. So let's check that one off. Let's make it easier to understand and to read. For one, I want to fix all my indentation because my indents are off. To do that, I'm going to use a function called Reformat Code, Control-Alt-L for me. But I can bring up this menu and I can just type Control-Alt-L, and then now all my indentation has been fixed. Brilliant. Let's add some comments. Capture input. I don't think we need comments for get component. That's going to be a pretty common basic thing in Unity. There's a couple things going on here. View rate speed as percentage of next speed. Turning force, add motor force. Do I add force twice? Wait, add alignment force. The force is sideways on the car that makes it move freely in one direction, and it's an opposing force if it wants to move sideways, because cars don't go sideways. Okay. And so anyway, some comments is pretty important. Another thing I like to do is in an update loop, update loops can get really large and really messy. So we tend to want to do something pretty clever where we check all of the different parts of update in their own little functions that are well named. So we're going to make a new function. It won't have a return, so it's a return type of void. And this will be, we'll call it capture input. Maybe capture isn't a good word. And we'll just put this here to there, and we'll call it an update. That code made no change to how this code executes, right? It does the same thing. In fact, it's maybe a little bit less efficient, but it's mute. But it is, sorry about that. It's easier to read. It's easier to understand. You might have a bunch of things like check for damage, check item speed up, check. You might do like all sorts of checks, and going through an update and having those as their own functions, that can be pretty helpful. That can be pretty nice. we could do the same thing here. We could have an add forces function, add those. We could have a alignment force function for that. That one actually seems maybe not super necessary, but I will, because I kind of want all this in one place because it's all this car physics. I'm probably going to tweak all these things just because I'm still working on it. But if this were done or closer to being finished and more likely to have to be less of an experimenty hacky zone and more of a refinement and adding features zone, then I might refactor this and move this out to its own function. So I'm going to use this as a demonstration to what am I trying to say? A demonstration to pulling a block of code out as its own function. So we can hit Alt Enter. We can go to the refactor code and then extract method. It showed up right over here for some reason. And then either a local function or a method. Let's just do both and see what the difference is. It gives me a little pop-up, and it's showing me a preview of the code. New method, let's call it add alignment force, and then it's asking if I want to input any of the variables, which I don't. And now that function has been generated for me. Turn any of the variables that are declared into parameters, which I don't want to do. Great. Maybe we could turn this into a function. We can refactor with a method, and we will return speed factor. And I'll call it get speed factor. And then I set that into a float, and then I use it, and then there it is. So now I have these functions, but they're not, let's get a comment. Let's use 3, and then that's going to get this summary appears, and it returns the speed as speed on a curve. I don't think it's a linear function. Returns speed factor value between 0. And now, because I've had that summary tag, if I hover over the function, it actually gives a little pop-up that tells me what it does right there. Oh my gosh, the ability to write code and include all these like documentation features, or even just comments, but fancier comments like these documentation features that tools like Writer can parse and turn into like helpful documentation. And then in the future, I'm using my own code. I'm using like a library of code that I wrote and I never touch it. I'm just like, there it is. That's great. I should sell this on the asset store. I won't, but that's fine for now. I'm not going to extract the forces as a function. But now it's much easier to see what's going on. Okay, we take the motor force, we get a speed factor, we use that to add our turning force, so you turn less when you are not moving. If the speed factor is 0, then your turning force becomes 0. And then we have an alignment force, which probably needs a better name. There's probably some word for that. Lateral friction. Okay, so now our code is easier to understand. And wherever it's tricky to understand, we've added comments. This force opposes any amount of velocity that is of the tires moving sideways? Maybe I made it more confusing. That kind of makes sense. Okay, so now we've added comments. We've added self-documenting comments. We'd probably want to add that down here. We've pulled some update functions into their own helpfully named methods, right? I don't really need a comment to capture input because the method, the function here, is named to capture input. So we're almost done. The last thing I said I would do is explain what the difference between extracting a method and a local function was. Method is going to be on the class level, like void and private and capture away can fix it. So it's going to be on the same level, while an inline function is going to actually declare another function right inside of the only function. And that the fact that we can do that will make more sense when we get into scope. But let's avoid that. You'll just extract its methods for now. If you want to use that feature, you also can just type that code yourself. And probably should have practice doing that and not rely too heavily on the auto generation code features. I like showing them off. It's not magic, we use our tools and make life easy. Okay, the last thing we want to do is make this code easier to change in the future. In a racing game, it's unlikely the player is going to be the only thing that is driving the player. And when any controller, character controller of any kind, player movement of any kind, it's highly likely that you will have things that aren't the player that are also moving in the same way. Whether you want to add an AI, like an enemy, like in a racing game, having other opponents, or you just want to be able to take away the player's input system and kind of control them for a little bit. Like they get near a door and you kind of, now they don't move, and we turn into basically an animation of them going to the door and through it. Or whatever. For many, many reasons, we want to often take our input and move it into a separate function from our controller. The biggest advantages are that we can replace input with things like AI that just calls the input functions. And we can replace the character controller without having to rewrite our input. It also allows us to have our input, which is often unavoidably complicated. If you're doing like an if-else tree of checking all the different buttons you can press, there's really no good way to optimize that. So having our code work in a way that we take that messiness and kind of compartmentalize it into just an input system, and then we start checking for all the annoying things that have to do with handling input. We do that in one place. And we have the physics and car movement thing. We do that in another place, and it's really nice to have a clean line of separation between these two elements. So for a small project like this one, where input is really just these two things, maybe this isn't that big of a deal. But it actually probably is for a driving game, because I want to support. I have a steering wheel. I have a game steering wheel for playing VR racing games. I want to support that. I want to drive that, even in a dinky 2D game. So. That's going to be more complicated to support that features and make sure it's working. I want to move that to another script. Maybe I have in the menu you can choose what type of input you want to have, and it will turn on and off different components. So you could have multiple input scripts on the player at the same time, and you just turn them on and off as the player switches from keyboard to joystick. So you can really handle them separately if need be. You probably use a different input system. There's a new input system that solves a lot of these problems, but anyway. So we're going to rename our car. We weren't done. Oh my gosh, we weren't done. I'm going out of order. Well, okay. We're going to rename some variables now, including car, and I'll teach you the renaming tool in Writer. Car isn't a great name now because we don't know what it does. We're going to have multiple things. We have the car controller, and we're going to have the car input. So we're going to rename car to car input, car controller. I rename that. I break everything. I have to go back into Unity and go to car, right? My script is broken. I got the warning. I got to go rename this into car controller, right? And then that will go here. And these settings may or may not be broken. Let's undo the change, and I'll show you a nice way that Writer works. Writer has a feature called renaming. It has a rename function. It is under the refactor menu. Shift F6. Shift F6 is the keyboard shortcut we want. So we can keep our cursor selected. We don't need to highlight it. We can just select it and go Shift F6. And we get a new name. And a checkbox, also rename files. We should definitely do that one. Search in comments and string literals. Usually good. In this case, it'll change the driving speed of the car controller. Like it'll change those two. I don't want that to happen, so I'll uncheck that one. And I'll change it to car controller. And now it's going to also rename the file. And because Writer and Unity are nicely integrated, it's not going to lose any of our asset IDs or anything. So your properties will still stay attached to the right objects. So really nice. Next, T. What's T? What does T stand for? No clue. Let's rename it to throttle S. Let's rename it to motor. No, what is this? What even is this variable? Steering. See, I forgot. I forgot the name of the variable. Writer has given me warnings. It wants me to use underlines for private variables, and I think that's fine. Let's rename under rigid body 2D. Oh, getting fancy. Using for all your private variables, not your serialized one, but just your private ones, to do just like underscore, and then they all pop up. And it's nice, and you can quickly see which ones are public and private, which when we later get into more complicated code is helpful at this stage of our programming careers, and it doesn't really matter. But having them all right there is nice. All right, let's make a new script and call it car input. Writer is using namespaces. We actually are going to use namespaces, but it's not yet, not in the video yet. Okay. Car input, and it's a mono behavior. Okay. I had to do that because I just right-clicked in Writer and hit add class. I meant to hit add Unity script mono behavior, and it would fix it for me. Same as right-clicking and creating a C# script. I just didn't feel like tabbing back into Unity. I could do it from Writer. This car input is going to need a reference to our car controller. It's going to need a reference to our car controller so that it can call a function to set the input values. Our car controller, we're going to take capture input and this update loop, and we're going to cut and paste. And now we have these values. And for the car controller, we're going to do a public function called set throttle, and the properties that this function will take is throttle is a single float, and that needs to be a value between 0 and 1. Right? -1 and 1 for going backwards. So we're taking input. We need to sanitize it. Prevent invalid input. And then do the right thing. And the right thing is to set our throttle. See, another advantage of using the underscore is this variable name and this variable name are the same because we are using the same word. And I could do throttle equals throttle, and that's nice. If I didn't have that, if this was called throttle, I would need to type this dot throttle equals throttle to disambiguate which ones I was talking about. But I am using this underscore, so I don't have to do that. Okay. So to sanitize our input, we need to prevent values less than -1 and greater than 1. And it's very easy to do that. We can set throttle equal to mathout.clamp. Take the value of throttle with a minimum value of -1, maximum value of 1. How do I know about that clamp function? Because it's the common math function in many coding libraries. It returns a result that is between those values. If it's larger or smaller than the values, it will just clamp it. It saves me an if statement. But we could check if throttle is greater than 1, debug.log warning, invalid throttle input. Or throttle is less than -1. So if our input is invalid, we give me feedback so I know what to do about it. Let's make a void set steering, float steering, and then steering equals steering, and steering equals mathout.clamp. 1. Okay. Great. So now we have these functions. This one isn't public, and I'm going to show you what that error looks like in a second. So let's go back to the car controller, and now we can use it. We can use car controller dot set throttle, and that will, I can pass in my property into that function, and then over here on this code, it will just assign it to that variable. Car controller dot set steering, and then I'm going to get an error. My autocompletes didn't pop up. Everything got weird, and it says it cannot access private method set steering here, right? And that's because it is a private function. In order for a script somewhere else to use it, it must be public. So there we go. Not a complicated input script. Still worth the exercise to demonstrate the point. There's more to do because this car controller is not set. We need to find it. Get component, car controller. And what if we don't have a car controller? This script will completely break. So we can do a little check if our car controller is none. And then we can log an error. Car input needs car controller. And then I'll see that error and go, oh, and I know what the problem is because it tells me what the problem is, and then I can fix it. Right? It makes it easier to debug when it tells me what the problems are. But there's another way. And that's an attribute called require component. Type of car controller, right? If you're seeing this for the first time, I have another video about attributes. So this will force this script to have a car controller. So I don't need to do that check to see if it exists or not because it has been enforced. For the same reason, I can now do require component type of rigid body 2D because this one requires a rigid body 2D. These require components are nice, but don't get too overzealous with them because it can make one thing very annoying, which is if I have car input, if I try to remove the car controller, let's say I'm trying to get rid of both of these. If I remove car controller, I'm going to get an error that says I can't remove it because car input needs it. It's forcing me to have it. So I have to remove them in the correct order, which would be input, then that, then rigid body. But the nice thing is if I type car input, it will add a car controller and a rigid body because the car input will add a car controller and car controller will add a rigid body if there isn't one already. So now my settings are all broken, but I have some default values. Hey, that made life really easy. Let's go ahead and check that in the car controller. If rigid body dot gravity scale is not equal to 0, debug dot log warning. Rigid body has gravity. Is this intentional? Okay. All right. So now that we have compartmentalized our input code in our car controller, we've renamed our methods to be nice. We've renamed our variables to be nice. We've renamed our functions to be nice and descriptive. We've added comments wherever the names aren't descriptive. I could definitely add more comments, but I'm not just going to type it all out right now. We are giving us warning messages when something wrong is happening. Let's go ahead and do that for steering as well. We've moved some update functions to their own well-named features, like capture input there, which cleans up our update loops, which can tend to get very unwieldy if we don't do that. We've extracted methods. We've, all sorts of little things to make everything work. The last thing to do, well, probably not the last thing to do, but the last thing I'm going to do in this video is make a namespace, and that namespace is another video. I don't want to cover that right here. I'll cover that somewhere else, and you can go check it out. But basically, it's an invisible object. It's a non-object object, right? It's going to put all of the I'm going to call it. What am I going to call it? Hunter's awesome code. And then I will wrap my class inside my namespace. Fix that attribute. And then car input, can't find the car controller anymore because it needs to be either using my car controller, but that's not right. It actually needs to be in the same namespace. Then it'll be able to access it. And now, if I have a car controller and a car input from somebody else or something else or somewhere else with those names, they're not going to conflict unless they're in the same namespace. So Unity Engine is a namespace that contains all the Unity features. System is a namespace containing all the system features. Okay, namespaces will be elsewhere. But here is a video explaining or walking you through actually doing all of the various steps that we covered during class. Okay, bye.